All right. So, as I said, for those of that's just joined us, um, we are wrapping up the Python part, which is part one, and we do hope you enjoy the session for the Python introductory Python. This is just the beginning, just to make sure that you get your hands dirty, you learn the basic concept of Python. This is not data science still. This is not machine learning still, but this is the concept or background that we expect each and everyone to participate in our Ario data science machine learning should have this basic experience. And we do believe by now you have basic experience, what is Python, how you can, make a loop, what is dictionary, what is, list, how you can do function, what is classes. That is the main aim of this, first part to get started and understand what it is. And as I said, for those that join us, previously we had in this Python session, we had pandas, data, NumPy, and other stuff in this, but we finally removed them that we are not going to discuss them. We are going to discuss them in the next step of machine data science. We have a bunch of details, Python stuff there, which you learn a lot. So we are not covering them, so we deleted them. I also made mention that we have projects. If you look at this one, this is project one, generating data, work on generating and visualizing data. Number two, downloading data, create a project focus downloading and visualizing data, working with APIs, integrate data from APIs, and develop a project that use external data. So these are three projects. We expect each one of you to select at least one project to see he does it very well. Somebody was asking, do we need to create a separate project folder, or can we use our existing repository? So I think the best one to, leave any confusion, is better you create a project folder, new project folder, and you name the project. For example, project generating data, project downloading, working with API, something like that, and you write your project. So by the end of this session by next week, we will give you same form to submit the link of your. In fact, if you already submit the link for your GitHub repository for you this assignment, then what you need to do is now to submit the link for the project as well. So this is different, which you already submitted for the link for your GitHub repository for your assignment. And then this is different, a link for your project in the Ario data science. So we will ask you by next week to share your project. In the next 2 weeks, we hope everyone complete the project. Does that make sense? Anyone with question again? Anyone with question? Question?
Yes,
Okay.
sir.
You're right.
Yes, sir. That means for the project we are so if you are if you intend to do three of these projects, so you have to create three repositories and submit the link.
Yeah. So you can do that. For each project, you can have three repo and you can submit that, because the main idea is when you do a project, for example, let me show you. You need to specify what the project is doing. So for example, let me show us an example of project, something. Okay, so the main idea how we do projects is that let me just give an example. This is it. So if this is your repository, you can have here, you explain what the project is all about. So let's go to, for example, Lukman. I believe he must have some projects just to show you. Okay, just give me a second. This one is, what is it? Okay, so for example, this is Lukman. Let's go to his repository, for example. Okay. So look at it. you can see this is Lukman project, one of the project. And then, for example, this is the title of the project, overview. You know, if you are having team members, but this one is not. This is our part of deep learning project. So these are the team members. This is the data set. This is what they do. So this, you know, for each project, you can, and then you can put your, you know, notebook or Python script or whatsoever in the folder. So this ensure that each project you call it, and you know, so this give you access. For example, when you are you know, applying for something scholarship, and you know, you nowadays, like if you're applying for position as computer science graduate, nobody check your CV, for example, if it is hands-on project, for example, machine learning. All what people need to do is share your GitHub repository. So if you share your GitHub repository, people will see previous project you did, your experience, which that is your CV right now. So that's why if you want to do two projects, you can have a separate repository, and then you can have like just like a headline like this, or even if it is something like this, just explain what the project is, what you know, how you can do it and whatsoever, and then you can add the content of the repository here. So this is how you do project in GitHub. Does that make sense?
Yes, sir. Thank you, sir.
Okay, any question? Any question?
Hello, sir.
Yes.
Sir, one of the questions is like I noticed that there are three different projects that you are expected to pick all or to pick one of such projects. So like project number one, I saw that you are expected to generate data and maybe to create chats using Python. Is that right?
Yep, I can hear you.
Yes, sir.
Yeah. So
Yes.
listen, so all these projects, they are inside the book that we did. All the projects, they are inside the book. So this is not something like rocket science. All we want you is to go and implement. So if you come here, so you can see project. We have 1, 2, for example, generating data, downloading this, you know, can you see this?
Yes.
We have this project. So if you go to this page 3101, generating data, let's go, and you'll be able to see the complete project implemented. It's not like we were grading you something, but what we want you to do is to try to do something based on the experience you have, what you learn, to try to implement a project to see that you have something that you can do. It's not just like to declare variable, you know, to do low, but we want to show you like how can you use all those experience you have to have something that you can say, okay, I implemented this, you know, I can see what I do. So that's the main idea. So let me just look at this. Just give me a second. This one is taking forever. What is this? Okay. Okay, just let me share my screen again to show you this. Okay. So this is the book we are talking about. If we go to the chapter that the last part of the book, let me see this. Okay. I just want to go to the part. Oh yeah, you can move around. Okay. Happy you can move around so the book. So let me go that. Okay. you can see this is a project working with APIs, but let's go up. So look at this one, downloading data. Can you see that? So if you choose to work on this project, look at the chapter, it explains the project. Can you see that? Can you see from the beginning to the end of the project? Can you see that?
Yes, sir.
From the beginning to the end, everything is implemented. What we want you to do is to replicate this example yourself. Follow the step one by one. And at the end, you feel like, hey, I implemented something myself. That's the beginning of you creating a project, Python project. Not only what we have been doing, create, function, because that is a bit what you did. We understand function, we understand class, we understand what is dictionary, we understand what is list. But how can we put all these things together to make an app or to make some project? That's the idea. So you can see the other one that we gave you, which is basically, let me go through it. It's called what? Generating data. You can see that generating data. So you can see this is complete project with that. So that's the idea. The idea is just for you to replicate these projects yourself to make sure that you understand the bit part of what you were doing. Does that make sense?
Yes, sir. Thank you, sir.
Okay. Yeah. So just to reiterate, let me go back. I can see some people just join. I already explained this, that we have finally come to the final part of our RODS Python Fellowship. Only some few things are left. Previously, we had in this, we have other tools to go through, which is NumPy, Pandas, and Matplotlib, which were basically data science tools. We felt this, what you already have, the Python skills you have now, the introductories, they are good enough for you to just get started, because we don't want you to take you more further, because we have already spent more time on these basics. And then we are now closing Python Fellowship. For those that qualify, do the assignment, do everything, that will now move to the second part, which is data science. So if we go to the second part, which is data science, as I have already shown, is that you'll be able to see that in our, this is deep learning, in our data science, we already have that, what I showed you. You can see we have the NumPy visualization, pandas, everything. You can see that we have these tools that can be used for that. So we felt like we don't want to spend much time in our Python fellowship because we will do them. So that's why we remove them. And now we are happy to tell you we have covered all the book, for example, getting started up to the classes. I'm not sure if we will be able to cover. I will ask Falalu file, which is the last part. Falalu, are we going files?
Yes, we are going.
Okay, so this is our last chapter today. If Falalu is not managed to finish it, then we'll be able to finish it tomorrow. But if we finish it today, then tomorrow we are not going to have any session, but we can join to answer question, to have question from you. Anything you want to know, we will join about for session. We will not have session. As I said now, any one of you is expected to choose at least one project from here. If you want to do all of them, that's fine. You are learning more. What you need to do is to create a separate GitHub folder project, and you do the assignment. We already have each of this one in a chapter. Just replicate it, complete it to make sure you understand the process. So that is it. So without much further ado, because time has already gone, I will leave to lead this session. Falalu, over to you.
Thank you, Doctor. Let me share my screen quickly. Yes, good evening, everyone. Today we are going to delve into one of the important chapters in this book. I think the chapter is, let me change it, is, I think, chapter 10. It's not 9, it's written. So it's chapter 10, where we are going to work with files. So in the first place, we all know files. Files are just identified by name and file name extensions. So in this lecture, we are going to learn a few basic things about files. We are going to learn how to work with files to enable programs to analyze large amount of data more efficiently. And we will handle errors because as we write programs, or especially when executing the programs, we are going to meet with errors. So we are going to handle those errors we encountered when running programs. And in doing such, we are going to introduce what is termed as exceptions. I know some of you are familiar with exceptions in other programming languages. And tomorrow, inshallah, we will talk about JSON module, and so that we can improve our program usability. So without wasting much of your time, we are going to start from reading from a file. So let's assume that we have a file. When we look at the name of a file, we will understand the format of that file, because not every function can read every file. For example, there's a function that you can use to read an image file. There's a function that you can use to read JSON file. There's a function that you can use to read many files. There are different bunch amount of files. There's HTML files, PDF files, many kind of files. So today we are going to use a function called read text to read text file. So if you can look at my screen, you will see a file name called FileDigits. This is a text file because the file name extension, the file ends with .txt extension, which means it's a text file. A text file is just a normal file that you can create with your Notepad program. So Notepad is everywhere, it's ubiquitous. So now let's assume that you have the file in your system. So it can be anywhere in your system. It can be in your desktop, or documents, or even on the internet. It can be on your GitHub repository. So it can be anywhere. So to read this file contains phi. We know phi, just a circumference divided by its diameter gives us phi. So in other words, we all know phi is 22/7, which give us number of digits. So it doesn't terminate. So we just keep getting digits. So this file contains those numbers, but it's limited to only 30 decimal places. So the numbers were split into 3 different lines with 10 decimal places per line. So let's start with this. Here from our program, you will understand that this is a library that contains a class called path. So we are going to use this class to point to where our file is so that we can have an object that we can use to read that file. So in other words, this path, we provide the path to where the file is stored. Then we use the object to call a function. So what is path? So in computer, we have two different paths. We have an absolute path and we have a relative path. So what is an absolute path? And what's the advantage of that? And what is relative path? What's the advantage? So now let's quickly look at this first before I explain what path is. So this path is located where this chapter 10.ipython notebook is, so that I don't need to use maybe slash, then the name of the folder where the file is. Then I write the name of the file. I don't need to do that because they are in the same location where this file resides. So I can just write the name of the file because they are in the same place. Then I will just run this. So when I run this, what happens? I think maybe I need to clear all output first. Yes. So when we run this, this is the output. What happens is here, create this path class, create an object that points to the file, where the file is, so the location where the file is. Then from there, we can use this object to read the content in this file. So what this method does, it reads the contents of this file. So because, as we said, some method returns values. So this method returns values. Therefore, the values that this method returns is the content of this file. So it returns in these contents. That's why we name these contents, because it returns the contents of the file. Then here we print the content. Understood? So when we run, this is what we have. So if you run this program in another environment, you will understand that when printing these contents, you have an extra line below, because whenever you use this read text, it always returns an extra line at the end of the output. So you can use this retrieve function that we use. I think Dr. Shamsuddin led a session that explain what right and left strip are. So this remove the extra space after the read text. So when you run the program, you will see that there is no extra space at the end, but you will not see it here because maybe when you use another environment, you will see it. So now we understand how to read text. Now let's move on. So look at this line. So we have two different dots. So if you are familiar with other programming, you know the method, what is termed as method chaining. So you can chain method on one another. If this one is a characters, then you can use alpha. You can use lower dot alpha. You can just concatenate method here. That is termed as this is termed as method chaining. So instead of doing this in two different lines, you can chain this method here. so that you don't need two separate lines for your code. Do we understand? Okay. Awal Abdullahi, you have question?
Yes, sir. Thank you for this session. Sir, I want to get clarification. You said earlier for us to be able to sort out the path, we have to create like an object. Are we going to use the same IDE to the text editor to create the object, or we have to do it in a different Python file?
No, this is the place. Here, we have the object here. This one create the object, then we have the object here that points to this file. So here is the object.
Yes, sir. I
Remember
mean, how
when-
do we create the object? Sorry.
Yeah, here it is. It's very simple. You just call the class. Remember our last class? We have the class cut. What you just need to do, you just write my kitty, for example, my kitty, then you put equal sign, then you put cut, for example. Then you have the object. If the class expects some parameters, then you can just put it here in the middle. You understand? So that we can have it in.
Yeah, I understand. Sorry, the question is the path, I think, is the file location.
Yes, it's the file location. So if the file resides where this file is, this chapter 10, let's have a look first. So look at chapter 10 here. You see? Can you see it?
Yes, sir.
So this chapter 10 is located in this directory.
Folder.
Yes, folder. And the file we are reading is also located here. Look at it here, file digit.txt. So we don't need anything. We don't need slash because they are in the same location. You can just write the name of the file because they are in the same location.
Exactly. So my question is, in a case where they are not in the same folder, I have to put that whole address, that whole file location.
Yes, that's where we are going now.
All right,
So
thank you so much.
Let's explain relative and absolute path. So these are the two main paths that we have in programming. A relative path tells Python to look for a given location relative to the directory where the current program is running. We understand? Then the absolute path is actually a location where the program, where the file is. Let's see the example here. So when we are talking about relative path, let's start with the absolute path. Let me do something. Now we have a file here. Let's look at this file here. So when I right click on this file, I will see this. When I say copy, look at it. If you like, you can press Shift Alt C. That will copy the absolute path. So when I copy this, I click on copy. So let me go back to where we are. Let's paste what comes here. So when I paste this, look at what we have. We have users. This is the name of directory called users. If you are working with Windows, so you have this directory called users under your root directory or C. Then after that, then we have number of users. We have public, then you have the name of your computer is here. Then we have documents, then we have other folders as well. So when you write program using this absolute path, because it takes the absolute path right from the root directory. If you are working with the Linux, you'll see home, right from home to where the file is. So if you write this program, if you write a program using this kind of path, your program may not be transferable. What I mean by that, someone may not run the program successfully because maybe he needs to change some things, because every computer has a username that is different from mine. Your computer, if you look at where this file is and maybe you right click and copy the path, you will see that here is quite different. Maybe here may be quite different. Under users, we have documents, but in document, I also have a directory called GitHub. Then I have another directory inside GitHub, which is called Ario Data Science. Inside Ario Data Science, I have another folder called Python Programming Fellowship. Then inside that, I have another folder 02 underscore Python dash lesson. Then inside that, I have another file, 5digits.txt. So this is an absolute path, a path from your root directory. So the advantage of this one, if you are working in your computer, is that this does not depend on the location. So you can just run, you can call this file, you can read from this file from anywhere you are because you are using the absolute path. We understand. So now let's look at it. I have it here, the file. So when we run this, so we have an error here. Code for the truncated that. Yes, escape. Yes, this happens because sometimes you can have this slash that can mean something different. For example, when you have /n like this. So this has a meaning in programming, which means what? New lines, yes?
Line.
Yes, sir.
Yeah, so then we have others like tab. If you need tab space, you can just use .t. There are many of them. Maybe you can learn them later. So to avoid this, what you just need to do, you need a raw text from this, so you can just put R here. So when you put R, I think it will work. Yeah, it works. So now we have the output. You see, we use the absolute path right from the C directory to where the file is located. So if you copy this and run it on the desktop, maybe you save this file somewhere in the desktop, this line will still, your code will still work because you are using absolute path. You get it? Then I try when to explain the relative path. So the relative path is relative to where you are running this file we are working on now. This chapter 10.ipython notebook. I created another directory that is called text files. So in the text file, you see it here. So we have this directory 02 underscore Python dash lessons. Then inside this, I have a bunch of files, and I have this directory, I have another directory, I have another directory, I have another directory. So I have 4 different directories inside this Python lesson folder. So inside that, I have another file. I just created this file. I just copy and paste the file inside this directory so that I have 2 copies. But this one is located inside another directory. So to access that file, you can use this and say text files, which is the directory where the file is, then we have this file digit, which is the name of the file. So the file is located in another directory. Therefore, you have to write the name of the directory, then slash the name of the file. Then when you run, now we have the output as well. So now the question is, what if the file is outside this directory? Maybe it's outside this. What will happen? Let's assume we have another folder that is maybe this 00_ stage -1 getting started. So we have the file that we want to read here. So let's create the file. Let's say we have this file. To create the file, you can just use this. Then just type the name of the file. Maybe you can call it a new file. My new location. Oh, let's call it grade or schools.txt that contains the schools of a test, for example. So how do we read this file? We'll put something in the file. Maybe you can say 53, 55, maybe say 56. Then we can save it. Then we can close it. So how do we read this file? So to read this file, we have a technique. So when you want to read from this file, what you just need to do, you have to go back a bit. How do we go back a bit? How do we get out of a folder? How do we get out of this folder? To get out of this folder, what you just need to do, what you just need to do, just put dot, then you put slash. When you do this, you are getting out of a folder. Then you can go to the folder that you want to go. For example, let's copy this. Paste it here. Now we want to go back, get out of this folder. So what you just need to do is just put dot, then put this, then you put the name of the folder. This, I think the name of the folder is 00, is it 0000? Thing is, okay, it's this one. So maybe we can try to copy. Oh, I'm trying to copy the let me do rename. Then from there you can copy. So then you can just put it here. Okay. So you do this, then you specify the name of the file here. The name of the file here. Whatever the name of the file is, that's it. So this is how to do it. So let's quickly move on. How do we access lines? Because now we know how to James Williams.
Yes, sir. Good afternoon.
Yes,
So
good afternoon.
I want to actually confirm with what you have explained so far. That was the absolute and the relative one. For the absolute, you have to copy the path address that also include the root folder all the way down. Then for absolute, if the folder that contains the file you want to reference is a sub of the file you are working in. It means you can just put in the subfolder, then the name of the text file.
Exactly.
But if it's outside of the folder which you are using to work on, and you still want to make reference to, you may need to put ... then the folder and the name of the file. What if
Yes.
they are too farther apart? They are too farther apart. Let's take, for example, sir. Let's say
Okay.
we have two different routes. Let's say we are trying to read a relative file from another root disk, like say
Like D.
an external hard drive. Is it still the
Yes.
same we're going to do? We're going to just copy the main head folder, ... the head folder and the name of the file.
No, if you have another directory, if you are reading from another directory, it is better to use a relative path. Like flash, so you can use F colon, then if the file is inside the flash directory, then you can just put F. If the drive assigned to the flash is F, then you can just use F.
Sir, I
Then
don't understand, sir. Could you give example just how to get friends? Let's say from a flash hard drive, you want to use
yes.
a relative path.
So from flash, what you just need to do, you can just do like this. Maybe the flash is F like this. If it's given as S, then if the data is inside the flash, is not, is not inside any folder, just write the name of the file, maybe text.txt. That's the name of the file. If the file is inside another folder, you can just use slash, then the name of the folder, maybe you have a folder called data, then you have another, maybe you have another folder, maybe data2, then you have the name of the file, you just write the name of the file, my file.
Sir, would that not mean using an absolute reference path? Because you actually have posted all of the file paths.
Yes, yes. It's not relative, it's absolute because it gives the absolute path. It's not relative. This one can work anywhere. You understand?
So
Whether
does it mean
you are.
does it mean sir,
Let me
does it mean
finish. The way to understand relative and absolute is the absolute works everywhere. It's not dependent on whether you are here in this folder or there in that folder or anywhere. You understand?
yes, sir?
That's
So
the advantage.
but for the relatives, sir, does it mean that when you are dealing with an external route,
Yes, yes.
you only have to depend on absolute. You can't use relative at all.
Yes, that's to the best of my knowledge, that's what I know. You need to
All right.
use absolute path.
All right,
If
thank
you are
you, sir.
another directory, because you are in another directory. If you are working with relative path, you are just let's see how let's go to the internet. I will show you relative path. Let me share my screen first so that you can see. Yes. So let's see how relative path, how it works. Control A, relative path. Relative path. Yes. So let's go and see. So let me explain, maybe using Faint. And my internet is not okay. So let's use Paint so that explain better. So let's see this. Can you see my screen?
Yes, we can. I can.
So let's assume here you have a directory. Maybe you can call it whatever you want, maybe you wrote or whatever. Then inside this directory, we know that we can have many directories. This. So this is the main directory here. This is white. So I have to change to. So let's increase the thickness. So we have this. That tick. So let's say we have this. So under this, we have all these directories. We have this one, we have this one, this one, and we have this one. So this one is a parent or root. I have not used a mouse, so what I've written here is parent. So this is a parent directory or parent folder where we have all this kind of folder. So we can have this folder. We can have another one here. We can have another one here. So if you are taking an absolute path, for example, maybe inside this, you have your file here. Maybe we can have this chapter 10. Let's call it file dot I 5 to book file. So let's say you have this file. So if you have another file inside this one, let's say our file is here. File text, let's call it file text or 5-digit, yeah, that's the name, 5-digit. Sorry, 5 digits dot txt. So if you are reading this file from this file, what you just need to do, you just need to use the function read text, then you supply the name of this file. So in that case, you don't need to specify anything. But if the file is in this, which means the folder is related to this one, you can either use absolute fast, you can take it right from here. The root to where the file is, or you can take relative, this file relative to this. You understand? So in that case, because this file resides here, you need to go out a bit from this folder. To go out, you just need to use /this. Then if the name of this folder is A, then you write A, which means now you are out of this folder. You go out, now you are putting /A means that you are inside this folder. Then you put the name of the file. If your file name is file, let's go digit. Sorry. dot txt, then this is what we mean. So you can just write the name of the file here, file score digits dot txt. So that's it. So if it's in another, if the file is in another directory, it means that it is not under this directory. It is in another directory, which means you need to use absolute fact because this directory has no relation, because this one has a parent, this one. This one has a parent, this one. And from this, we don't have another parent, which means we have to take another route, which is here, which is another directory, maybe called E or whatever. Then you specify the name of that other directories that you have. Any question on this? So let's switch
For
back
me,
to.
I understand it with this. Thank you very much, sir.
So let's.
Hello, sir.
Yes.
So when you I have just observed that when you print out, the output shows numbers that are in decimal. That is
So can you see my visual code?
that is plot. Yes. I mean not this demonstration that I've just done. I mean inside your VS Code editor in the environment.
Okay, now I am inside VS Code. Can you see my screen?
Yes, no, sir.
Yeah.
Actually, I can only see the drawings you have just made.
Okay, so let me reshare my VS Code. Sorry for that. So can you see my VS Code now?
Yes, sir.
Okay, so what's the question?
I mean, like for now, when you print the output, we are going to see 3 different outputs in form
Like
of
this one?
plot. Yes. So what does this plot means? What does it mean?
Which plots? Is there any plot here?
I mean, like the first one, 3.1415926.
Yes, this is pi. Pi is just 22/7. When you divide 22 divided by 7, this is what is termed as pi.
Yes, sir. I mean, so what does they mean? The outputs. Now, what does they mean? What are they standing for?
Yes, so the output, what we are doing here, we are just demonstrating how we can read content of a file. So initially, we had a file called filedigits.txt. Let me open the file. Can you see the file?
Yes, sir.
So you see the file here, 3.142, etc. Then 141. So these are the content of the file. You can add other contents if you have ones. So here is what we have. So we want to read the content of this file. Your content may be different. Maybe you have a record of students. Maybe you have a record of attendance. You can have many things. Record of transactions. Record of many things. So the rationale behind doing this is to learn how to read content of a file, how to read the content of a file. So here we have the file. Then here we read the function read text that helps us read the contents of a file. So here we use rstrip to remove the extra space. Then here we print the content. So this is the phi, 22/7. We all know phi in math.
Yes, sir.
Yeah. So that's 22 if you are working with
Is the read underscore text function or method, is it inbuilt or we
yes,
made
it's
it?
yes, we borrow it from a library. It's not, it doesn't come with Python. It's come with Python, but we get it from this library. So it's inbuilt function. So we didn't create it. So it comes from this library. You understand?
All right, sir.
This is the class, then we write the class, then we open bracket, then we specify the file, then we use the object to read the content of the file. So how do we access lines? Sometimes this one, we just access all of the contents of the file. Now we want to access lines by lines. How do we do that? Remember when we were dealing with text, some function of a text, we use this split function. I think with list, I think we use this split function, but I couldn't remember. But it works with a string as well. So what this method does is it will just split your lines into different lines. It can take arguments, but here we are just taking it as default. So how do we do that? So to do that, what we just need to do is to, let's do this. So we are going to use the file we had before. Oh, okay, it's not this one, it's called phi digit. So phi digit, that's the name of the file, phi digits. So this one, we point to where the file is located, then here we have the object, here we read the text. So from there, to get the contents, we use this function. But we want to split the function instead of just giving the output like this, because when we print, it will just print this one. But let's assume we want to print this line, then next line, then next line. So for those that are familiar with other programs, they know how to use hash_nest in Java and maybe C#. And even those that works with Android, they know that. So we use this split so that we can have line by line, line by line. So this will split the whole content into their respective lines. So this will, okay, let me do something. Let me do this. Instead of printing this, let me use print lines and see the output. So look at what we have. So this function splits will just split this output into lines and will give us the result in a list. Now we have a list. So when we want to print out the items in a list, we all know how to do that. What we just need to do, we can just use follow so that to print, that's the best way to do it because you can have many lines in it. So if you want to go for hardware of doing this, you can just use print, then the name of the lines, then you can say print like this, which is hard. I know that no one will go into this lines, then you put this indexing 0, then you go to the next 2, you do this, and you go 3, you do this, then you change this one, then you change this one to 2, which is very, very hard if you have many data, because we don't know how many lines we have. I think it's better to use this for loop so that we can automate the process of printing lines by line. So when we do this, we can just have the output line by line. So imagine you want to further process each line. Maybe you want to print only the first 3 digits here or whatever, then you can do that. But using without using this technique, I think is impossible to just print. You will just print the content. So this is how to do that. Yeah, it's another example. We have a text file, weather.txt, that contains the weather for some days or month. So here we use the same method to read the content. Here we have the contents. Here we split each line. Then here we print line by line. So you can also further process this line. For example, you may, okay, let's move on first because the time is going. So working with files content. So when we use this split method, we can work with the content in the file. So how do we work with it? So let's see the first example. So look at this example. This example, we have a method called Fahrenheit or to Fahrenheit, whatever. Then we have this method expects parameter, which is in degree, for example, maybe in degree. So from there, it's further process this because we use this function because this method returns data in form of string, just like the input method we've been using, that input method to get input from the user. This method also returns a string. It returns data in form of string. This one returns as well. So here we read the file we have. Then here we read the contents of the file. This points to the file. Then here we read the contents in the file. Then here we split the contents by lines. Then we have the list. Then here we process the list item by item. Then here we call this function. Maybe you have the mark or scores of students that you want to grade. You can grade your function, call it grader or whatever. Then you can call the function here, grade. So you supply the score, then it will keep giving you the student's grade. If you like, you can put the respective score here, then you can put the score here, then you can append the respective grade for that particular student. So let's move on to another example, working with the contents of the file. So the same as above, we have the file here, 5 digits, then we read it, then we split it into line by lines, then we have the list. Then from there, we created an empty string here, a variable that contains an empty string that called file string. So this is a variable that contains nothing but this empty string. Then here we process the list by picking one item at a time from the list. Then we put it in the file string here. So here we are concatenating the first content with the second content, with the next content until we reach the end of the end item, the end of the list, until we reach the end of the list. So here, when we are done, then we print the file string. So here we print the length, the number of spaces occupied by the characters. So when we run this, this is the output. So you see, unlike before where we have our output line by line, now we have it in one line. So we are merging it here. But we have one problem here, because if you look at the output here, you will see that there is this space. So how do we remove this space? So to remove the space, we can use this left strip to remove the extra space. So, and then concatenate. Remember to concatenate before to remove the space before concatenating. So this function does the magic. You remove the space, then you concatenate on the previous ones. Then it will just keep doing that until we reach the end. So when we run this, now we have our file formatted correctly. Then we have the length, the number of characters here, including white space. They are 32 in number, including this dot. So let me say this. We read from a file when necessary. So whenever you want to write a program, read from file when necessary. Sometimes when you read from a file, don't read it. You read once, then do all your processing, then you write once. It's better. But when you have a simple thing that you keep reading, you keep calling the file, this one is computationally expensive. If you have computer science background, you know, the data structure or algorithm design, you will understand that there are some codes that are computationally expensive in terms of memory or time. So reading from a file is computationally expensive. So just read file when necessary. So you can have very large file. So how do we read from large files? The same thing. Unless it may take a while when reading from large files, then, or even when processing, it will take time, then reading from a file that is comparatively very small. So when Python read from a text file, it interprets all text as I say it in the file as a string. So whether you have numbers, Python will just consider those numbers as string, just like the input function. So if you read in a number and want to work with that, so you have to convert that in using int or plot function that we've been using before. So this is an example. Let's say we have another file called 5 million digits.txt. So this file is lengthier than the previous one because it has 1 million digits in it of 5. So let's see the file. So when we run the file, this is the file. Can you see it? So the file is very, very big. It's very big. So this number is huge. So how do we read? So here As previously explained, we all understand this. So here, what we do is slicing. I think we did slicing when working with a list, and also string, because you can slice string, you can slice list. So here we are taking from 0 to this -1, you remember? So we are taking 52 individual objects from the file string. And here we are printing the length of the whole contents. So when we run this, this is what we have. Remember, it took a while when running this program. It's just took a while, unlike before, because we have very large number. So here we only took 52 numbers, including the dot. Because remember, this is string. String, when you have like you have a name like this, say Arewa data. Sorry, Arewa data science. Yes, so let's say we have this. So you can print the first 4 or 5. When you do like this, look at what we have. We have the first 4 items or characters. So because we write 4 here, it will start from 0, item at 0, 1, 2, 3, because we have this value -1, because it starts from 0. If we want to start from somewhere, just put it, start from this, so we have this. So the same thing applies to this, because as we said, when we use this function, it returns the contents in form of string. So we have the string, and here we use split lines, then here we remove the spaces, then here we just extract what we want. We use the technique called slicing. Then we have the output here by using the function, print function here. Then here we ask the len function to tell us how many characters are there in this variable. So let's move on. Now we have this. So let's say we want to know if the 5-digit contains our date of birth. So how do we do that? The basic assumption here is we have the content of the 5 in this variable called 5 string. Now 5 string contains 5 digits. Those millions digits is stored here. Now we have additional lines here. The first line here asks the user to impute or enter his birthday in this format. You put the the month, then you put the DD, that's the day, then you put the year. So that's, for example, if you were born on February, for example, you can write 2, then the day, maybe the 10th of February, then you can write like this. Then the year, maybe you were born in 1994, you can write 94. So this is the format that we want. Then here we have a variable that stores what the user entered. Then here we check. So this is a conditional statement that checks if what the user entered is in the 5 digits. So if it's there, it is found that we have this sequence in the 5 digits, then we print this. If it's not, then we print this. So now let's run this. So let's ask one user, okay, there is something, okay, yeah. So I should have used this. So now I am prompted to impute a date of birth. So let me just use any. So let's say someone was born in the month of December. Maybe he was born in maybe 2nd of December. Then in 1999, we can do this. So when we run this, you see your birthday appears in the first. So when you look at the sequence of digits in the 5, you will come across this line where we have those digits I imputed. So this is quite useful. Maybe it can happen that you have a file that contains list of maybe student. Now you want to check whether that student exists in the file. Then you can read the file. Then you can ask the student, what's your name? Then when you have the name here, then you can check if the name is in the student list. Maybe it's attendance list that you want to check. Maybe something else. You can just put this line is what the user has given is in the list we have. Then if that's correct, you can either print it or do any further processing with it here. If it's not, then you can print that in your else part of your code. So now let's move on. Now we know how to read a file. So can we write a file? Yes, we can do that. That's what is called I/O operations. Because either we have input or we have output. So now we want to write a file. So how do we write to a file? To write a file, we use another function. Instead of read text, now we have another function called write text. So from the name, you will understand that this function is going to write to something. So to see how this works, let's see the first simple example that we are going to store some text to a file. So as previously did, we have this library, fast live. Then we import this class called path. Then we write the path to our file. So this is the first file. So here, the assumption here is that the file resides in the same directory where I am writing this code. Then here we call the function to write this text. I love programming. So what will happen if the file does not exist? We will see that later. So if the file does not exist at all, this function will try to create the file. So let me run this. So when I run this, you will see that you see it here. Even if I delete it, let me delete it first. Yes, I want to move it, cycle it. Now the file does not exist at all. So when I run it, I run this, now you have the file has been created, programming text, because this is the name of the file I provided. If I say now I have programming 02, when I run, you will see another, you see it. So if you want to automate the process, you can do that. So now we have the file created using this function. So this function just write a single line. So how do we write multiple lines? So we can do that because this function write once. And you should always, okay, let's move on. I have the note. So how do we do that? Look at this one. Here we have a variable that contains the string. Then I use the same variable here, but I use this operator to concatenate this to the previous ones. So here it's just like saying, please Python, go and get the contents of in the variable called contents, then append this value to it, then go to the next line and leave it blank. Then here you append another one from the previous ones. So you keep going, you keep adding, you keep adding. Now you have the variable that contains this variable, this line. This variable contains this one, and this one. Now you have all the content in this line. Now, here you provide the name of the file that you want to write these values. Then here we use the function to write all that we have in this variable. So what you need to understand here is that when using this function, write text, you should always remember that if you already have the file, maybe you suffered a lot or you gave someone to type something in a text file. Now, instead of reading from the file, you use the function write text. Instead of using read text, you use write text. And you provide some values there or whatever. The function will erase, will override the previous content, which is very, very disastrous. So you should always remember, if the file already exists, it will just overwrite it. So even if you have billions of characters in it, it will just overwrite it. So you have to be careful. Although there are other functions that we will learn as we go. Maybe when we go deep into Python, we will learn other functions that we can use to read content of a file. There are many functions. There are inbuilt functions like open. So there are modes that you can use. You can use those functions to read a file in a reading mode. So you are telling computer just that you just want to read the file, and you open the file that you telling the computer that you just want to read the file, and you can tell the computer that you want to write the file, or you want to maybe make append data to the file. So there are many modes, maybe later, but not this function for now. So there is what is called exceptions. So Python uses special object called exception to manage errors, because when we write or execute programs, errors happens. Sometimes without our knowledge, you can write a good program, but when running, the user can impute unexpected values. Maybe you write a program that you designed to add numbers, but instead of converting the values you get from the input function, now you just directly apply some mathematical functions to the data already collected, so you can have an unexpected result, which can lead to what is termed as exception. So whenever an error occurs, it makes Python unsure of what to do next, because what it encounters was unexpected. So it doesn't know what to do next. So it creates what is termed as exception object, because it doesn't know how to proceed. So if you write code that handles exception, the program will continue running. Otherwise, it will just halt. In other words, your program will just crash, which includes a report of exception that was raised during the execution of that particular code. So let's see the first example. The first example that we are going to see on exception is handling zero division error. So this kind of exception happens when we try to divide a numerator with 0. You know, we can divide numbers. We can perform arithmetic on numbers, just like this one. This one is just a function that receives two numbers, the numerator and denominator. Then it will just divide the numbers, then it will return the result. So when we have this function, we can call it with many things. Let's run this function. So let's give it some jobs to do. Let's say divide for me 2 divided by 2. So this one will return the value 1. See, we can give it another values like this. Say divide for me 1 with 0.00000001. So this one is very large number. How many millions? So you see this quite big number. So this is how this function will work. But the problem is, what will happen if I supply 0 here? So you see the exception raised, 0 division error. 0 division error. So it tells you that you are dividing by 0. So how this is called exception. So the same thing applies to this. When you write a print function, you tell it to divide 5 by 0. So the result is too big that the computer has no memory to store the value. That's why it will tell you that. See, division, 0 division error, because the number is too big. Division by 0 is too big. The number is large, too large. You see, we just divided by this. This is not even closer to 0. See, 0, 0, 0, 0, 0. What if we put this like this? So the number will be so big. You see, is almost close to the number of atoms in the universe, because we have, I think, 2 power 200. So this number is very, very large. You see, this number 0.00 is it's not close to 0. So what if I have millions of zeros here? So the number will be so big. So as we go close to zero, the number is becoming big and bigger, bigger and bigger. So this one, the computer has no memory to store this value. So let's move on. How do we avoid this error? Because whenever this kind of problem happens, imagine you have millions of code. Now you come to maybe you have 2 million of code. Your code runs successfully until you reach 1,998,098, for example. You are close to maybe print the result. Now this happens. Your program will just crash. So you have to start over. So how do we avoid this? So fortunately enough, just like other programming languages that use a try catch, so Python also has try except block to do that. And before that, you can check, you can anticipate, because sometimes what you just want to avoid is dividing by zero. Dividing by zero. So if you like, you can just check if the denominator is zero, then you can raise the exception. You can say that this is happening. So let's run this. Okay, it's another function. So if I call this div2, if I call div2, sorry, it's div2, now I have 2, maybe I have 5. So when I run this, you see now we have the result. But what if I put 0? Now you see I still have error because I asked this to raise the error. So how to go about this? To go about this, you have to use this try except block. So you can extend it. There is also else part, but I don't think that the books covers that. So we are going to just do this try except. So here you are telling the computer. So when dealing with files, you can use this try because sometimes the file may not exist. So you can use try. Please Python, try to locate this file. So if the file does not exist, your program will not crash. It will tell you that this your file does not exist. Then it will just continue running from where you have. So first, the computer will attempt to do this. If it couldn't, if there are some errors that will happen, especially like this, you can list many exceptions here if you want, but here we are just going to, we are making it simple. So you try to do, tell the computer, try to do this. Can you try to do this? So if this is solvable, then the computer will do it. If it's not, then it will just go to the except file. Just like if else statement. So if this one is successful, it will execute this. If it isn't, then it will do this. So let's run this. So when we run, you see that you can't divide by 0 because we can't divide by 0. What if we change the value? Let's make it 2. We make it 2. Now we see we have the result because this one has a solution. So when we do this, you still have this. So we use exception to prevent crashes because we say that when you write your program, when you come across anywhere that exception can happen, then your program will just crash. But it will tell you the reason. So you have to go to that location and maybe debug your code. So let's demonstrate this example how we can use an exception to prevent crash of our program. So considering the first line, we are just printing. The second one is just guiding the user to enter Q if he wants to exit the program or quit the program. Then here we have a while loop. So this one is forever loop because it will just keep doing this until we break out of the loop. So when we want to break out of the loop, we were guided by this line. It tells us to enter Q, then press enter when we want to quit. Otherwise, just keep adding. So when we run this program, this line will first execute it. It will ask for the first number. So in the second number, you put Q, then it will just quit the program. Then, so if the first number is Q, it will just quit. Then second number, if the second number is Q, it will quit the program again. It will not show you the result. But if you supply number here, you supply number here, then you will get the result. Otherwise, you will not. So let's run this. Then before we run, here we have this function int. It will convert the user's input into an integral form. This one will do the same as well. Then we make a division here. Then here we print the result. Look at this. All of these are inside the while loop. So let's run. So when we run here, we are prompted to add, to impute numbers. So let me impute 12 as the first number. Then the second number, I impute 6. So I expect to see 2. So you see that I have 2. Then the code continues running. They expect me to add numbers. Maybe you write a program to grade a student. So you just keep imputing the marks or scores, then the program will keep giving you the grades. Or maybe you write a program that will accumulate maybe your daily transactions. So you can do that as well. So you know how to do that. You just have the variable. In the first place, you have total equals to 0, then you keep using total plus equals to the value provided next. So let me write 12. Let me write 2. So you see I have this 6. So now I want to quit. I'll just put Q. So now I quit. So what if I impute something that cannot be converted? For example, if I put R here, at R here, I think something unexpected will happen. So you can use that exception to prevent the crash. So let's use this else block. So give me 2 numbers, I will divide them. For example, here, almost the same like that. But here, what I will do, because for this one, let's rerun it. For this one, if I impute 12, and then the second number I impute 0, you see, I still have this division by error problem. But this one, what I will do, instead of doing that, I will just, when dividing the value, I place the expression that does the magic, that does the division here inside try. So I will just ask the computer, can you try to divide first to convert this, and then convert this, then divide it. So if this division is successful, it will just store the answer here. Otherwise, it will just tell you this. So if it does, then it will print the result in the else part. So let's do it. So now I'm prompted to impute numbers. So I'm going to impute 12 as the first number. Then I will impute 2 as the second number. So now I have the result. So second, I impute this, I impute 6 as the second number. Now you see I have the result as well. So what if I impute 12 and I impute 0 as the second number? So when I do this, you see that you can't divide by 0. So let me just quit. So now you see we have an intelligent way of handling this problem. So the same thing applies to I/O operations. Sometimes you may want to access a file that doesn't exist. So in that case, you will see an exception. So for example here, when we look at this one is alice.txt. So we are trying to read, not writing, because when you try to write, it will just create the file. So now let's see our directory. Is there any file called Alice? I don't think that we have any file called Alice here. So these are alphabetically arranged in alphabetical order. So we don't have any file called Alice. So let's tell the computer, please, can you locate a file called Alice and read the content and encode the content, maybe the encoding of the text in the file is in this UTF-8 format or encoded. So when we do this, you see that we have an error. What's the error? No such file or directory called alice.txt. So this tells you that the file is not found by the computer. Maybe you mistyped the file name or even direct the computer to a wrong directory. So therefore, you will get this error. alice.txt is not found. That's the message here. It's not found. Therefore, it is up to you to revisit your path here. Maybe it is not the right path. Maybe you need a relative path or you need absolute path. So you have to go and check where the file is. If you like, you can just right click on the file, then you copy the path, then you paste it here. So you have the complete path file. So this is it. So you see that when file does not exist, we have exception as well. So to do that, to avoid that, you can also use try except. Try except. So here we have the file path. Then here we ask the computer to try to read the file. So if it couldn't, it will tell you this story. Please, sorry, the file. Then here we supply the path here, does not exist. So when we run this, look at what happened. So the file alice.txt, because this points to this path, so it tells you the path here. Remember how we display the container variable using this method. So I think that's all we have for today.
Sir, I have a question.
What's the question?
Yeah, I mean, when you use the try exception, must we always specify the type of error we are expecting, or can't we do it without writing that type of error?
Yes. You should always try to give the kind of exception. So if you want to learn about exception, you can go to the Python website. You will see different kind of exceptions. different kind of exceptions. So you have to specify, and unfortunately enough, you can add as many exceptions as you want. So if you expect this kind of exception, you add it. This kind of exception, you add it. So you can create object as well of exception, but this is beyond the scope of this class. But maybe as you go along, you will see how to do that.
Okay, sir. Thank you, sir.
So that's all we have for today. Maybe tomorrow we'll continue from where we stop. I think tomorrow we will delve into
Yes, sir. What if we say except for okay, except exception?
You say?
What if we say except exception? Is it okay?
Except exception. Yes, we will talk about that. Maybe tomorrow we will talk in detail about that when we deal with more on files. So because of the time constraint, I think it's time for Freya. They call it for Freya. So see you tomorrow. Bye bye.